Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework. First, looking at the probability vocabulary in our M&Ms. Probably what to focus on the most here, our outcomes are all the possible results that you can get from an action, like flipping a coin. Your outcomes are either heads or tails. Spinning a spinner, all the outcomes would be all the different spaces that the spinner could land on. Rolling the die would be all the numbers that you could get by rolling the die. What we really want to focus on here is the difference between the experimental probability and theoretical probability. Now, theoretical probability, this is the mathematical model. So if you think of the probability of flipping a heads with a coin, you've got two sides to the coin, and only one of those sides is heads. So the probability of flipping coins mathematically would be 1/2. So that is theoretical probability. As opposed to flipping a coin 10 times and noticing that heads came up 6 out of the 10 times, this is not the theoretical probability. This is the experimental probability, because you're actually doing the action itself and telling how often something happens. So that's the key difference between the experimental and the theoretical. This is all based on the mathematics, while the experimental is based on an actual flipping of a coin or spinning of a spinner or rolling of the dice and telling how many times, counting the number of times you get the desired outcome. All right, so let's take a look at this. Tom keeps all of his favorite marbles in a leather bag. Right now he has, let's highlight these, 5 red marbles. He's got 4 blue marbles, and he's got 3 yellow marbles, for a total of 5, 9, 10, 11, 12 total marbles. If he randomly chooses one marble to give to a friend, what is the probability it will be blue? Well, what are the desired outcomes in this situation? The ones that we're looking for are blue, and there are 4 of those. So 4 out of the 12 are blue, which simplified is equal to 1/3. So that means that the probability of pulling a blue out of the bag is going to be equal to 1/3. That's supposed to say blue, that's supposed to be blue. Okay, so Tom does not really want to give away a blue marble and would like to change the probability to 1/10 instead of 1/3. So what can he do here? How many marbles would he have to add to the bag? Okay, so I'm going to show you the ratio. First of all, we know there's 4 out of 12, correct? Hey, come on. There we go. 4 out of 12 in the bag. Now, this is written as a fraction, but technically it's not really. What I'm going to do here is going to break rules for adding fractions, because we're not technically adding fractions together. If I were to, let's say, what do we need to change this to? 1/10? We've got 4 blue marbles in there, and we're not taking any out. We're adding other marbles in. So the only way to get a 1/10 ratio is if we have, that would be equivalent to 4/40ths. We have to add 28 marbles with none of them being blue to the bag, so we end up with that 4/40 ratio. So there'll be 40 in there, but only 4 of them are the desired outcomes of blue, and so we would have to add 28 total marbles that were not blue to the bag. Okay, here's a different situation. Your team is in charge of games at CPM Amusement Park. One of the games involves a robotic arm that randomly grabs a stuffed animal out of the bin. You need to set up the game so that the probability of a customer grabbing a teddy bear is exactly 1/2. Okay, so how would you set up the bin? Here's my explanation here. You just make sure that half the animals are stuffed animals, right? So you can have as many animals as you want in there, as long as half of them are teddy bears, then you've got the probability. So what if you returned to check on the bin and found that there were 4 teddy bears left, but 12 other animals? So the teddy bears are the desired, right? And we've got 12 other animals, and the common mistake students will make is to put a 12 in the denominator for the total. But that doesn't say there are 12 total animals, it says 12 other, meaning there's 12 other animals in addition to the 4 teddy bears, meaning there are 16 in there. So right now, this is a 25%. This is 1/4. And you need to make changes to get it back to 1/2 or 50% teddy bears. So there are 2 different things you could do. You could either add more teddy bears, or you could take away some of these other animals. Let's start by what you would have to take away. If you wanted to have this be half with the same number of teddy bears, you would have to have 4 teddy bears and 8. So you'd have to take away 8 of the other animals. So it'd be 1/2. 4/8 is 1/2. That's relatively easy. But a lot of times what people think they have to do is if you were to add 4 more teddy bears, that would do the trick. The problem is when you add 4 more teddy bears, you no longer have 16 animals. You now got 20 stuffed animals. So, oh, hold on for a second. If you add 4, then you have 4 being added to the bottom, and so that would be 8 out of 20. So by adding enough, let's say what happens if we add 6? We had 6 teddy bears, and that becomes 10 over 22, which is not 1/2 yet. So how about adding 8 to the top and 8 down there? So you had 8 teddy bears, which means you got 12 teddy bears, and you had 16 animals. Now you've got a total of 24, and that's the combination that you need. So you're either going to add 8 teddy bears or you're going to remove 8 of the other, and that would get your ratio back to a 1/2 ratio or a 1/2 probability. All right, so let's break this into 2 parts. This one really pretty much straightforward. 4 different fractions that are equal to 1. There are an infinite number of fractions that we could write down here. I just wrote some random numbers. As long as you've got your numerator and your denominator are the exact same number, that will be a fraction that is equal to 1. And the rectangular part. If we've got this rectangular part that I've drawn here, oh, what happened to it? Hold on. Oh no, I lost my artwork. Oh well. This is a rectangular park that is 150 yards in this direction and 125 yards in this direction. And it says that if Debbie walks around the park 2 times, how far will she walk? Well, that's where we have to figure out what the perimeter is. So the perimeter is going to be the total sum of all of these sides. And that would be, what would this be? 150, 150 is 300. 125 and 125 is 250. That means that the total is going to be 550 yards to go all the way around 1 time. And so if you want to go around 2 times, that's going to be 2 times 550. So that would give you a total of 1,100 yards. What happened to my answers? I must have deleted something here. This is horrible. Okay, so, but luckily I remember what the answer is to this one. So now, if she wants to walk 1 million yards, how many times would she have to walk around this? Well, every 1 time is 550 yards, so we're trying to figure out how many 550s can we fit into a million. So this becomes, oh, let me change the color here, back to this. This becomes 1 million divided by 550. And the answer ends up being a repeating decimal, which is like 1,818 point blah, 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 blah. But we would have to round that up to 1,819 times that she would have to walk around this park to get to 1 million yards. Let's go ahead and take a look at that. If you used your calculator, Every time you go around is 550. So that, yeah, so it's 1,818.18. Now, if you just rounded that down to 1,818, that would not be the right answer because 1,818 times 550 would leave you 100 yards short of your goal of 1 million yards. So we would have to go around one more time, and I suppose you could just walk 100 yards and call it quits. But, you know, once you commit to walking around, he likes to walk around completely. So I think that's the best answer. All right, and then the last problem. Find the perimeter and the area of each figure below. I figured the perimeter is pretty straightforward. You know, you just add up all the sides that make up the shape. This can get a little confusing sometimes. You know, these dashed lines are not part of the triangle, so they would not be a part of the perimeter. You would just have the 14, the 7, and the 9 to get 30 meters. And this is kind of an interesting, I like that they drew this type of a trapezoid because this is one where I can kind of show you how the formula works. Because the two bases in your trapezoid are the two sides that are parallel to each other. Whichever one is base 1 or base 2 doesn't make any difference. But the two of them, when you add them together and take half of that, it's kind of telling you that you, oh, stop it, dude. I need to lock those things down. Is telling you that you're finding the average of the two. So what does that mean to find the average of the two? Well, let me just go ahead and draw a little line right here. If I were to cut this piece off right there, that would be like 2 meters right there that I would cut off, and I would add that onto here. So this becomes 13, and this becomes 13, and you notice that this shape now is a rectangle. This becomes 13 by 9, right? 13 meters this way, 9 meters this way. So this formula basically is a way of transforming your trapezoid into a rectangle where you've got base times a height, which gives you the area. Okay? So yeah, so what we did was we took the 11 and the 15, added them together, took half of that, that's 13, and then 13 times 9 gives you 117 square meters. Here, your formula is to take half of the base times the height. Now, the base of your triangle could be any 3 sides, but what you've got to do is you got to measure the height from your base, the first perpendicular line that you can create from your base, which would reach from your base to the highest point of your triangle from your base. And so that's where you got to create these imaginary extensions on the lines so that you can get out here. And the distance from the highest point to the base at a right angle is 4 meters. So this is the height, even though that line is not any part of this triangle. So we're going to multiply the formula, base times height, and then cut it in half because triangles are 1/2 the area of any parallelogram with the same base and height. And you get half of 36 or half of 4 times 9. Either way, this gives you 18 meters. All right? All right. Hopefully all that makes sense to you. If you ever have any questions on any of these problems and watching the video wasn't enough to clarify, do not hesitate to send me an email, and if you want to hook up in a Google Meet so that we can talk about it a little bit more, I'm always welcome to do that. Okay, you just need to let me know if anything wasn't completely clear. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, walk